Can you guys hear me now?
Yeah, I can hear you.
Loud.
Okay, I'm so sorry about this. I put the microphone on the wrong system.
Okay.
I'll start at the beginning again, sorry. Okay, so hello everyone, I'm sorry about that. Today we're going to be talking about molar masses, and we'll be able to convert between masses and grams. So we're going to be doing a lot of stoichiometry or like math calculations for the next few weeks in our next few lessons. So for this week, there's going to be 4 questions to test your concepts in a Google Forms quiz. In the same place as always, I would highly suggest you guys to do them as they're good practice. And as always, I'll give written feedback and post your grade on Google Classroom as well. And as always, if you have any questions, just email me at my address, jasonzhang@alphademic.org. I would answer any questions or suggestions to improve this course. So today, we're going to begin by doing some review. I know we talked about it a lot, but I really need everyone to truly understand this concept because it's extremely important. It's review of moles and molar masses. And I want to make sure everyone understands how to do that because everything would build upon this concept. And then after that, we're going to find the mass of an individual molecule. So instead of a big mass, we're going to get a really small mass for each individual atom because an individual atom is like super small. So it'll have a super small mass. And then at the very end, we're going to start something called stoichiometry, which is basically converting between moles and grams with the molar mass that we're going to learn about in the very beginning. So that's the lesson plan for today. Now we're going to start off by reviewing what moles are and molar mass. So you might be wondering if it's like this mole we're talking about. No, moles in chemistry have nothing to do with the animal mole, which is a kind of a pest. There's actually a few in my backyard, and it took forever to get them out. But no, it's not that type of mole. I know they're sometimes so cute, but they can be bad for your garden as well. But for the moles that I'm talking about, so it's moles to calculate the number of molecules in a lab. So when we deal with anything in the lab, there are large amounts of molecules. So for example, if we have like 10 grams of gold, which is about the mass of 10 paper clips, we have around 3.06 times 10 to the 22nd atoms of gold. And that number is humongous. So chemists have defined a number so we can deal with smaller numbers than bigger numbers. I know we did this before, but this is a review just so everyone can understand. I promise you at the very end, we're going to get new stuff. So that's why we define the concept of moles. So we define a mole as a fixed constant of the value 6.02 times 10 to the 23rd. So 1 mole of any substance is 6.02 times 10 to the 23rd molecules. And it doesn't have to be chemistry. Like 1 mole of Pokemon cards is 6.02 times 10 to the 23rd Pokemon cards. 1 mole of dogs is 6.02 times 10 to the 23rd dogs, which would be a lot of dogs. So it's basically a number, just like dozen. Yeah. So molar mass. So the molar mass can be found on a periodic table by summing the atomic masses of each element. So for example, let me write. So the molar mass of like CO2 is basically the sum of a carbon and 2 oxygens. So we look at the masses on a periodic table of a carbon, which is 12, and then the masses of an oxygen, which is 16. So we just do 12 plus 2 times 16, and that gives us 44, if I did it correctly in my head. So that's how we find the molar mass of CO2. So, but here's a new definition of molar mass that's what we're gonna need for our future problems. So the molar mass is also the mass of 1 mole of a substance. So for example, the molar mass of water is the mass of 6.02 times 10 to the 23rd water molecules. So in my example, this molar mass that I calculated of carbon dioxide, it's the mass 44 grams in 6. And so 44 grams is the mass of 1 mole of CO2 atoms. And that's the conversion we're going to be using. So before we just found the molar mass as 44, but now know that it has another definition. It's 44 grams per 1 mole of a substance. And 1 mole is this number of molecules or atoms. So that's what I was talking. The molar mass has units of grams per mole. And from now on, we're going to be using that specifically. In the past, I said AMU, atomic mass units, but 1 AMU is the same as 1 gram per mole. And for our calculations, we're going to need the gram per mole. You could cancel out units. So just know that. From now on, when you do molar mass, you give your answers in grams per mole. Okay. So here's an example. So oxygen, there are 2 oxygen atoms in a molecule of O2. And we know that because of the subscript down here, it tells us there's 2 oxygen atoms. So from the periodic table, remember we find the mass on the bottom of the periodic table. So it's 15.999, which we could just round to 16. So to find the molar mass, we do 2 times 16, which is 32. In the past, we just said AMU as the units. But now we're gonna need our new units, which is grams per mole. So it's 32 grams per mole as well. For today, I want you to give your answers in the latter term, and please put your units because they're useful. I want you to type your answers as in 32 grams per mole when I have a question on the next page. So here's an example problem. So please type your answer into the chat, PM me privately, please, so other people don't get the answers. So what is the molar mass of NH3 in grams per mole? So please type your answer in the chat when you solve this problem. Okay, I see a lot of people got the right answer. A few of you made a few simple mistakes, but so to tackle this problem, you have to first see how many elements are in each atom. So there's 1 nitrogen, And then this subscript down here at 3, it means there's 3 hydrogens. So looking at the periodic table, the mass of nitrogen is 14.01. And the mass of hydrogen we could just assume to be 1. So you either input this answer, or you could actually do the math and you get 17.01 grams per mole. So make sure to keep on with the units because that's going to be useful in the future. So it's 17.01. In the answer I had below, I used the whole number, but it's okay to just assume hydrogen to be 1 in this case. Doesn't matter which way you do it. You can just do the whole decimal, or you could just abbreviate it as 1. You could just assume that atomic mass of hydrogen is 1. So I'll clear everything. So let's try another one. So please put your answer in the chat, PM me privately. So what is the molar mass of H2O2? This process is just the exact same as last time. Some people are asking about the units. It's grams per mole. Okay, we're doing a lot better this time. Everyone who got it, who submitted in the chat, got it correct. Just like last time, we have to look at these numbers. They're our key. So we first have to see how many types of each atom there are. So there's going to be 2 hydrogen and 2 oxygen. And I'm sorry that my O's kind of look like zeros. Please just bear with me. That's an O, not 20. So hydrogens are basically 1 and oxygens are 16. So either using a calculator or doing it in your head, you get 34. And what's the units? Grams per mole. Yep, and that's our answer. Okay, so that was our review of moles and molar masses. So now, with that information, we're going to now try to find the mass of one individual molecule. So I'll go back to the water example. No, actually, we're going to do a chlorine example. I'm sorry. We're not going to do water. So suppose we want to find the mass in grams of just one chlorine atom. So for this, we're basically going to use the molar mass as our tool for calculating the grams of one substance. And we kind of knew that since it has units of grams per mole. And we basically already know how much a mole is. Remember, a mole is basically 6.0 6.02 times 10 to the 23rd. So we can do some simple calculations and get the mass of 1 gram, 1 molecule. So from the periodic table, remember it's right here, we know that the molar mass is 35.45. We're cutting down the last 2 digits and we're kind of rounding here. So the molar mass is 35.45 grams per mole. So in other words, 1 mole of chlorine weighs 35.45 grams. So that's what this fraction tells us. This fraction, grams per mole, it means if we have 1 mole of chlorine, we have 35.45 grams. If we have 2 moles of chlorine, we have 2 times 35.45 grams. If we have half a mole of chlorine, we have 1/2 of 35.45 grams. So this is basically a ratio here with the grams per mole. An easy way to think about this is if you want like 2 moles of chlorine, you could start off with 2 moles and then you multiply it by the molar mass, which is 35.45 grams per mole. And then you can do some canceling out of units. Since you're multiplying this is the multiplication, the moles cancel out, so the only unit left you're with is grams. And if you do 2 times 35.45, you get something around, let me do it on my calculator, 70.9. Sorry, this is a 9. So that's how we can convert get grams from how many moles there are. So that's basically 1 mole equals 35.45 grams. And now we're remembering that 1 mole is 6.02 times 10 to the 23rd chlorine atoms. So on the next slide, I will show you how we solve the problem. So intuitively, since 1 mole is 6.02 times 10 to the 23rd atoms and 35.45 grams is 1 mole, we could divide the molar mass by 6.02 times 10 to the 23rd to get the mass of 1 individual atom. So basically, to get the mass of an individual atom, one way to think about it is 35.45 grams is in 1 mole, but then 1 mole is 6.02 times 10 to the 23rd atoms. So once we divide that out, we get an answer, and it'll be in grams per atom. And that's the mass of 1 individual atom. So if you put that in your calculator, 35.45, and you divide by 6.02 times 10 to the 23rd, you get that an individual atom weighs 5.9 times 10 to the negative 23rd grams. And there's another method I'll show you that can solve the problem the exact same way. It's called dimensional analysis. If you're good at math, you might have learned this in math class as well. You're basically just trying to cancel out units. So for example, let me clear. You start off with what you have. The only thing you have right now is the molar mass, which is 35.45 grams per mole. And then after that, you know that 1 mole is 6.02 times 10 to the 23rd atoms. Since you know that 1 mole is equal to 6.02 times 10 to the 23, this fraction is equal to 1. So you're basically multiplying by 1 to both sides, which is allowed in math and everything. You can multiply both sides by 1 and you'll get the same product. But when you do this, notice that you can cancel out the units. I'll have them in orange. Notice that the moles here and the moles here cancel out. And then you're left with grams per atom. And that's the unit we want. So then after we cancel out the units, we can just divide the numbers, 35.45 over 6.02 times 10 to the 23rd. And then we get 5.90 times 10 to the negative 23rd, which is the exact same thing. So this is basically the same method, except we're showing the cancellation of units to get our desired units of grams per atom, which is what we want. And then here basically explains we're multiplying both sides by 1, which I just explained. So that's how we can do it. So you can also use any method. You could either just divide it by 6.02 times 10 to the 23rd, or you could do this dimensional analysis unit, which I would recommend as stoichiometry problems get harder, and just cancel out the units. But the thing about the second method is you have to know the units of each number. Okay, so now we're going to be doing an example problem. So please type your answer into the chat when you are done. So basically, what is the mass in grams of one oxygen atom? And here is the periodic table, which would help you with the molar mass. So you can use either method. You don't have to use a calculator. You can if you want. You can either put the division in the chat, or you can just put your answer in scientific notation. And you should get a really small answer. So I'll give you guys some time to think about this. I know this problem's a lot harder, but I'll go over it. Okay. So I'll go over the problem. So you're going to start with what you know, which the only thing we know right now is the molar mass. So today, this is why I told you guys to remember it as in grams per mole. So we start with 16 grams per mole. Now we want to multiply both sides by a conversion factor that we know is 1. And the only conversion factor we have is 1 mole is 6.02 times 10 to the 23rd atoms. Since we're multiplying both sides, we could cancel out the units. So in this case, notice that this mole gets canceled out and this mole gets canceled out. And then in the very end, we're left with grams on top and atoms on bottom, which is the exact unit we want, since that's the mass of one atom. If we get anything in grams per atom, that's the correct answer. So using a calculator, we can get 2.66 times 10 to the negative 23rd grams per atom. And that's our correct answer. So you might be confused with this unit grams per atom, and how do you know that that's one oxygen atom? Well, if you're still confused, you could just multiply this again by one atom. And again, you cancel out units. You cancel out this atom and you cancel out this atom. And 2.66 times 10 to the negative 23 times 1 is 2.66 times 10 to the negative 3 grams. So that's the mass of one atom. So if you get the units of grams per atom, you're done, because that's the mass of one atom. So good job to everyone who got it right. We're going to practice another one just so you guys are more comfortable. Oh, sorry, there was a hint. So what is the mass in grams of one molecule of HCl? Whoopsies. So please type your answer into the chat when you have solved this problem. So here's a hint, just in case this is challenging. So this is the exact same thing as last time, except the molar mass of HCl requires the sum of two elements. And then the exact process is the exact same. Okay. Great. I'm seeing a lot of good, correct answers in the chat. A little behind replying to all of them. Sorry, I'm a little slow getting back to everyone, but everyone who replied to me got it correct. So I'm sorry if I didn't respond to you. There's just a lot. So the first thing to do, as always, is to find molar mass. So the molar mass is 1 plus 35.45. So the molar mass is 36.45. And what are the units? Grams per mole. So just remember the units are always grams per mole. But then that's not the units we want. We want grams per atom. So we can just multiply it by our conversion factor, which is 1 mole. I'm sorry for the ugly handwriting. 6.02 times 10 to the 23rd atoms. And then as always, we just cancel out the mole. We're left with grams per atom, which is the unit we want. And then everyone, it's around 6.05 times 10 to the negative 23rd grams per atom. But then you times it by one atom, so you can just leave it off with grams. You don't have to do that atoms on the bottom. So it's 6.05 times 10 to the negative 23rd grams. So good job, everyone. Or 0.6. It depends on your rounding. So this is the last example for one molecule. So what is the mass of one molecule of methanol, which has a chemical formula CH4O? So this is similar to the same as the last problem. So take your time, find the molar mass. Like I'll stress that today, molar mass is the key to every problem we solve today. And you could approximate carbon having 12, hydrogen 1, and oxygen 16 as always. And this is the part where a graphing calculator may help, or any calculator actually. So for this problem, the hardest part is looking at the subscripts. So there's one carbon, there's 4 hydrogens, and 1 oxygen. So I think a lot of people, some people are missing out the 4. The subscript 4 means there's 4 hydrogens. So when you do the math, it's 32 grams per mole. So I know it can be sometimes hard seeing the subscript. So once you do that, everything else is the same. We have grams per mole, but we want grams per atom. So we could just use the definition of a mole, which is 1 mole is 6.02 times 10 to the 23rd. It should be atoms, it should actually be molecules, but it doesn't make a big difference. So I'll say molecules. And as always, the moles cancel out when you multiply. If you have a mole on the top and a mole on the bottom, they cancel out. And you are left with the answer of 5.32 times 10 to the negative 23rd. Not positive 23rd, it's negative 23rd grams. And that's our answer. Or 3-1. It depends basically on how well your calculator can round. Okay, for the last thing today, we might not finish all the problems, but that's okay. I just want to get you used to this stoichiometry calculation. The good news is we're converting moles to grams, which would be very similar to the last problems we just did. As long as you keep all the units out, it should be the exact same. And similar method, we're both canceling out units. So let's get going. So sometimes in the lab, we want we know the amount of moles in a substance in a bottle. They'll tell us like this bottle contains 5 moles of nitric acid or something. And we want to know how much it weighs in grams so we can actually measure out with a scale the right number of grams that we want for a chemical reaction. So today we're just converting from grams to moles. Sorry, we're converting between grams to moles, not moles to grams. So if we know we have like 10 grams on our scale, we want to know how much moles that would be so we could do our calculations with stoichiometry. Now, I recommend having paper and pencil for these problems, as well as on the homework problems like these. I'd recommend having a paper and pencil as well to solve them. And we're going to use a method called dimensional analysis, which is the exact same method I just showed you with the last problems, where we cancel out the units, and that's all we do. Basically, cancel out the units till we get our desired unit. And I highlighted in red on top, our important conversion factor for today is molar mass, which is the exact same thing we talked about earlier, molar mass. That's why I reviewed it, because it's such an important thing. In the last problem, remember that molar mass was also an important conversion factor, with the fact that 1 mole is 6.02 times 10 to the 23rd of that substance. But in this problem, molar mass is the only conversion we need. So here's a compound called ethanol. The molar mass I calculated for you from the periodic table like we've done in the beginning is 46.1 grams per mole. In other words, this fraction means that 1 mole of ethanol is 46.1 grams of ethanol. Because we can multiply this side by 1 mole and the moles would cancel out and we'll have 46.1 grams. So thus we have 2 conversion factors we can use for our problems. We have this one, which basically divides, if we let this be equation 1, so this is equation 1 dividing both sides by 46.1. Since we divide the right hand side by 1, so if we're dividing it by 46.1, this cancels out because they're the same, so we have it equal to 1. So that's why this is a conversion factor that's equal to 1. And if that factor is equal to 1, we can just take the reciprocal, and so this factor is also equal to 1. So these are the conversion factors we're going to be used to cancel out units, so we can get our desired grams to mole conversion. Okay, so here is an example problem. Suppose we have 10 grams of ethanol and we wish to determine the number of moles. So the first step in any dimensional analysis problem is to start off with what we have. In this case, the only thing we have is 10 grams. So we want to start off with grams. So that's why we put it here first. But we don't want grams as our final unit. We want it in moles instead. So this is the molar mass. And remember, we can find the molar mass by summing up the individual atomic masses in the periodic table. So it's 2 carbons, 6 hydrogens, and 1 oxygen. So you go to the periodic table, you find the masses of each individual element, and then after you add them up, you'll get 46.1. So you multiply it and make sure the grams is in the bottom. The reason being, so we could cancel out these units later. So like right now, there's grams of ethanol on the top and a grams of ethanol on the bottom, and we could just cancel out those units. And then we're left with moles of ethanol, which is exactly what we want. So then we just do the math, 10.0 over 46.1, and plugging it into our calculator, we get 0.217. So that's all this dimensional analysis is. We're basically starting with what we have, which is 10 grams of ethanol, and then we'll multiply it by a conversion factor that is equal to 1, like I said in the last slide, because it's the molar mass ratio is always equal to 1, and then you're just canceling out the grams and you're left with moles. So I hope everyone knows how to do it. And we're going to do some practice examples. Since we're a little out of the time, the first one I'm going to do with you guys, and then the second one and third one I'll let you do on your own. So how we're going to start these problems, we're going to start with what we know. So we know two things. Grams, there's 5 grams of nitrogen gas, which is N2, and we know the molar mass, which is 28 grams per mole. So we always want to start with the grams. So we have 5 grams of N2. And remember, G is the abbreviation for grams. And now we want to use the molar mass to cancel out the grams. So we could either multiply it by 28 grams per mole on the top, or we could do 1 over 28. So like we can either multiply it by 28 grams per mole, or we could do 28 grams on the bottom by 1 mole on the top. But in dimensional analysis, our goal is to cancel out the units. Since there's a grams of N2 on the top, we want to use this fraction so we could cancel out the grams. So it's 1 mole of N2 over 28 grams of N2. We cancel out the grams, we're left with moles, and that's what we want. It asks how many moles are left. So we just plug 5 over 28 in our calculator. Let's see what I get. 0.179 moles.
Excuse me, I was kicked out of this meeting because my Wi-Fi wasn't that good. So could you just please explain that process again?
Sure. When did you get kicked out? Just this slide, or was it the previous slide as well?
The previous slide as well, I believe.
Okay, so I'll explain everything on this slide. So basically, we're gonna start with what we have. So what we have is 5 grams of N2. So that's why we started off with it right here. This thing right here, 5 grams of N2. And then we want to multiply it by our molar mass. But the thing is, we want to get rid of the grams of N2 because we want the moles of N2.
Mm-hmm.
So by our molar mass, we want the 28 to be on the bottom and then the moles on the top, so we could cancel out the grams of N2.
Okay.
And then since we multiply, we cancel out the grams of N2, so we do 5 over 28, and we plug into your calculator, and it gets 179.
Okay. So you divide like the 5 grams by like the molar mass, right? Like
Yes.
the desired amount, the amount that they want you to figure out how many moles are in blank grams divided by the molar mass of the element.
Yeah. And the reason we could divide it, because on the previous slide, I said this ratio is always 1, because 28 grams of N2 equals 1 mole of N2. So that's what the molar mass says. And on any equation, we can multiply anything by 1 and still get itself. So that's why we can convert moles to grams with this way, because this fraction is, this orange fraction, how do I get it? Wait a second.
Okay.
Finding my pen. Okay, this fraction right here is equal to 1.
Okay.
Because we found it's an equality. So we're multiplying 5 grams by 1. So on this side, this will be equivalent to what we started with, which is 5 grams. So after we cancel it out, we realize that this is moles. So 0.179 moles is the same as 5 grams. So
Okay.
Thank
you.
Okay, you're welcome. So since we're out of time, we'll just do one last problem and then I'll end the class. This is the exact same thing. How many moles are in 50.0 grams of hydrochloric acid, which is HCl? Remember to convert your grams to moles for this problem. So please put your answer in the chat when you got the answer. Here's a hint. The first step you need is to find your molar mass. So you get to look at the periodic table, look at the masses. There's one hydrogen, one chlorine atom. So you can use that to find the molar mass. I'll give you some more minutes, some more time to think on this problem. Everyone who put their answer in the chat was correct. So far. Okay, since I see a lot of people have already done it, I'll just do this one so we can end the class here. So the molar mass is 35.45 plus 1, which is 36.45. And the units, grams per mole. Remember the units always be grams per mole. So we start off with what we know, which is 50 grams. And then we want to multiply it by our molar mass ratio, which we know is 1. But we want to cancel out the grams, so the grams must be on the bottom. So we have 36.45 grams of HCl per 1 mole of HCl. By dimensional analysis, which I hope you guys all mastered by the end of this lesson, we just divide out the terms. And then once we do our little calculations, which is basically just using a calculator, you get 1.37 moles. And that's what everyone got. So good job, everyone. We're going to do this problem next class period since we're out of time. I'm sorry. So the lesson recap, today we reviewed moles and molar mass. We can now find the mass of an individual molecule using a method called dimensional analysis, and we have a moles to grams conversion. So for homework today, we only have 4 problems. There's going to be 2 problems here, I believe, 1 problem here, and 1 problem here. So that's the layout. So I would highly recommend you guys all go to Google Classroom and go to the homework tab or assignments tab and try out these problems so you have more practice. Because next class, we're going to build on top of the material we learned today. So next class, we're going to start here, moles to grams. Grams to moles conversion. And then we're going to go back and do, we're going to go the opposite way as well as some other conversions. So, like I said, 4 questions, and if you have any questions, feel free to contact me. Thank you everyone for joining this class today. I enjoyed teaching you guys. See ya. Bye.